Hello, welcome everyone. Thank you for joining us for this live stream event. My name is Rebecca and I'm the event planner of the Microsoft Reactor in New York. Before we begin, I'd like to quickly review two items, our code of conduct and our event guidelines. So for our code of conduct, Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we just ask that you're mindful of your commentary remaining professional and on topic. For this session, it will be recorded. It's available on demand, probably in the next 48 to 72 hours on our Microsoft Reactor YouTube channel. If you've not been on one of our live streams before, just know that if you want to engage in the chat on YouTube, you do need to have a channel created, an account set up. So if you haven't done so yet, you can do so now, or otherwise you can always reach out to us separately and we can try to get those questions answered at a later time. So that's pretty straightforward right there. And we'll move on to the main event. So today's session, we have Gwyn, a cloud advocate here at Microsoft, and Bruno, a Microsoft AI MVP, joining us today. They're going to discuss drones, face detection, and Azure IoT. Let me pull them up on the screen here. Hello, all.
Hi, everyone.
I'll pop myself up too.
Hello, everyone.
Hello. Thank you both so much for joining us, for taking this time to run through this interesting topic today. So super excited. For the audience, just note that this session will go for about an hour, right, guys?
Yeah.
Yes.
And there'll be time for questions throughout. So feel free to drop into the chat. All right. I'll let you guys take over.
Thank you, Rebecca. Hi, everyone. We've got quite the audience. I know this is a very interesting topic, Bruno. Thank you very much for sharing this session with us. There's a lot of people interested in it. It seems like such a cool project, lots of cool technology. We're talking about drones, IoT, face detection, all this cool stuff. But first of all, how are you doing? I see a Canadian flag right there. You want to tell us a little bit about yourself?
Sure. So, hey, hello, everyone. Happy to be here. And yes, I'm in Canada. I live in a city near Toronto. Not a Canadian, probably noticed the accent. I was born in Argentina, live in Spain, moved to Canada 5 years ago. It's been a nice ride. And hey, I've been an MVP for the last 14 years. I really love technology. And this drone was kind of a personal project that I started last year, started to tinker around, try to figure out a couple of things. And hey, this is a nice story to learn a couple of, as you mentioned, cool technologies. And hey, I hope you like it.
Absolutely. I think the best way to learn is to just put together these fun little projects. So it's easier to like piece things together and instead of like just going through like boring theory and stuff like that, right? So I think this is going to be pretty fun. We got some people in the chat saying hi. Juan says hello, friends here. We got another one that says hello, everyone. So huge hello to everyone. Tell us where you're checking in from, all those kinds of things. And I'm going to be paying attention to the chat throughout the entire session. If we have questions, anything like that, please let us know. But Bruno, I know you're going to be driving this one. You got a lot to teach me. So you want to get started?
Yeah, sure. So just to set up the context a little, you will see a slide. I am not going to use a lot of a slide. This is mostly coding. I am a crappy programmer, but still a programmer. So I will try to code everything from scratch, but I will start with a couple of slides to set up the context.
Of course.
And by the way, the best way to contact me, everything from today will be shared, the code, the slide, I will to share this later, but the very best way to contact me is via Twitter. In my Twitter, Bruno, you can see there. Hey, let's start. So drones, IoT, face detection, computer vision, plenty of stuff, and let me tell you how or what we are going to do. So Python will be the main language. I've been doing a lot of Python in the last couple of years, mostly for machine learning projects, but this was a nice excuse to learn a new set of features and technologies using Python. Then computer vision using OpenCV. I will try to avoid to talk about communication because UDP is not the most friendly communication protocol ever, but this is what we have. So I probably drop something there. But this is the main knowledge that if you know this, you're probably going to be fine. That's myself. I work in Havana. That's amazing. This is a disclaimer that I would usually in my sessions. This is how to not use this in production, or maybe yes, but it's up to you. So let's start. Let me show you where it all started. So a couple of, I really can't remember now with COVID days, my calendar is a mess, but I think it was last year, a colleague basically introduced me to this very small drone. I am going to show this in the camera for a few seconds, but it's a toy. It's basically a toy.
Wow, it's very small.
It's very small. It's very nice. It's very nice. And it's also cheap because when you think about drones that have an SDK and you can program the drones, this is the $1,000 drones or a couple of thousand. So they're expensive. This is not so expensive. This is the $100 drones, and depending on if you have some promotion or whatever, you can even get this for $60.
Oh wow!
But the cool thing about it's amazing. But what really tricked me when I started to see the drone is that I saw that the features of the drones are basics. This is a standard toy drone. You have a 720p camera, you have a 10-15 minutes battery. It's flying well. It's not the best drone, so it flies well enough. But when I started to figure out what we can do and whatever, a friend of mine pointed me in the direction to a video where I see a couple of kids, small kids, doing some basically programming the drone using Scratch. Is a programming language. It's a visual programming
Scratch,
language.
yeah. Mm-hmm.
That you connect blocks. So you say drone, take off, drone, move right, move left, fly, to do whatever. So I said there is something there. $100 drone. That's a budget that I can spend, and my wife is not going to scream. And there should be an SDK. So I get the drone, and then I realize that there is an SDK for education, but there is no unofficial SDK.
Okay.
But somewhere deep in the web, in the Rise Robotic website, which is the company that manufactures this, there is a PDF that basically explains how you can create your own SDK. Or what basically, it's not how you can create your SDK, but how you can interact with the drone. So when you connect to the drone is a Wi-Fi. It will start a couple of Wi-Fi. It's a Wi-Fi hotspot. So you connect to the drone, you have your IP, and then you have a couple of ports, UDP ports, to interact with the drone. You have one port to send commands. This is where you say, hey, drone, take off, and do a flip or whatever. You have another port that you are going to read information from the drone, the battery level, the temperature, the time of flight, the accelerometer, how it's internally working, and a third port to get to access to the camera. So with all of this, I decided, okay, if I can write some code to try to figure out what to do. So I started to write some code. So this is basically what I set up to show you today. Because the drone is a Wi-Fi drone, I have my machine, I have my personal desktop connected via a wired cable to internet, and I am going to connect via Wi-Fi to my drone. And I explained this because you are going to see for sure a couple of times during my presentation that the drone get disconnected, that I need to connect again.
Yeah.
I mean, remember, this is a toy. This is not a professional drone. This is a toy that you can use. But I want to give a setup, give a context of how is my current setup, so you don't say, why is he pinging the drone? What is happening there? This is how it works. Okay. In a real scenario, I will love to go to New York, go to the reactor, and make a hello world, making the drone fly.
Yeah.
We can't do that right now. I'm going to save the flight demos to the end, so I avoid breaking the drone right now. So I'm going to do the most boring hello world ever, which is basically connect to the drone and get the battery value.
Okay.
And that's it. That's my slides. That's what I want to tell at the beginning. If you are okay, I can start to do some coding.
Of course. I think everyone loves code. Everyone loves demos. I think the cool part about being like an engineer or developer is like, it looks like you had just enough of the pieces, right? You didn't have everything figured out, but you had just enough for your curiosity to be like, I have something here. I have a little toy drone. I have like barely a PDF with some commands here. I can make this work. And now you're going to show it to us.
Yes. So Python, super simple. I did also this demo a couple of times using C#. So if someone feel more comfortable in the .NET world, I will share the repository so you can see basically the same, but with using .NET. But here I will start with the three main libraries that I'm going to use. Sockets, remember, I am going to open a couple of sockets to connect via UDP with the drone. Time, to double check timeout and this kind of stuff. And threaded, because each one of the sockets will be open in a different thread, so I don't block the main application. Very simple. And again, before this, I was only doing machine learning with Python. So for me, it was the first approach to get to know how to work with sockets, with threadings, this kind of stuff that we usually don't do a lot in machine learning. Once I have this, my next step will be, okay, let's write a couple of functions to see how we are going to receive data from the drone.
Okay.
Again, it's super simple. I will open later. This is Python, so I will define this and open this later. A socket, and I will have two sockets, and please do not do this at home. In an eternal while true, with a try catch there, I am going to read information from the socket. And depending, remember I told you that we have three sockets, one to send commands, one to read information from the drone, like the battery, the time of flight, and the third one for the camera. So depending on the socket, I will read chunks of data in 1024 or 226. And the important topic here is that once I know how to read this info, I can split the info and understand that, hey, here I have a big kind of an array of values, and the item in the position 21 is a string with the battery, with the percentage of the battery, 60%, 55%, 40% of whatever. So again, it's not a very complicated code. I know I can do better, while true. Don't do that at home, please. You can blame me if you want, but it's something that testing to make it work, it's good and nice enough. So next step will be, okay, how do I send information to the drone? So I will have here the send command. And this is basically the same function, right, 3 times. And what I have here is I will have a timestamp. I will have a timestamp to control kind of the timeout. Then I will send a string to the client socket, to one of the sockets, important. And to learn this, crying a little, doing a lot of try, trace, we need to encode this in UTF-8. And then in the previous functions, I was checking the response as one of the value. If I don't have the response in 5 seconds, I will define, hey, this is a kind of a timeout. I didn't have any response. Return false. Otherwise, I will return the response here. And the other functions here are very similar. It's kind of I kind of overloading the first one, so I have a string, data string, or even OK or error. But 2 sockets, I am sending info to the other, I am reading info to one, and I'm reading info to the other. Right. So now I can start to basically define the connection to the drone, how I'm going to connect to the drone. And this is also very easy. I know the IP, I get connected to the drone, so once I connect to the drone, I know which is the IP that I'm going to have in the drone. And once I know the IP, I can, because of that PDF that is available somewhere there, I know that the port that I'm going to use are 8889 and 8890. So I can open my sockets here. I can say, okay, let's open a client socket and a state socket to send commands and to read commands. Very straightforward code, and I'm basically almost there to have a fully functional SDK to work with my drone, because the next step will be, hey, remember the 2 while loops that I showed at the beginning? Let's run this while through in 2 threads, in 2 separate threads, and Python is going to do the magic to run everything for me, and I will have basically this function running all the time. So with this, just as a quick recap before writing the app, I have a couple of functions to send info to the drone. I have 2 sockets connected to the drone reading information for specific ports from the drone in different threads, so I can start to write an app. And the first app is the most boring app ever. We'll define a battery variable. I will send a first command. Sorry, I didn't mention that. In the SDK, they specify that once you connect to a drone, the first command that we need to send to the drone is a string command. If we don't this, the drone is not going to work. And then I can start to read commands. I will set up a sleep for 5 seconds, and I will show the battery value. Okay. This is all based on the definition of the PDF. So that's basically it. This is my hello world, the boring hello world for this. So let's copy the path and let's run this on Python. Before running this on Python, this is the disclaimer. I need to connect to the drone. Once I remember, I am connected to using my Ethernet cable. So what I'm going to do here, I turn on the drone. When I turn on the drone and I go to the Wi-Fi networks, and I start to take a look at the list of the network, somewhere here, let's wait a second, there it is. So this network, Telo 589327, this is my drone. I can set up Windows to automatically connect here to the drone, but that's not, I learned that that's not the best way to do this. Okay. So what I usually do, yes, it's because we'll connect, it will realize that it doesn't have internet connection, so it will stop the connection. So what I will do is I have this kind of trick here where I will ping my drone. I am not connected right now, so I start to have these timeout responses. Yeah. And in another tab, I will use a netsh command to connect to the drone. So this is a standard Windows command that is going to try to connect to the drone, netsh, wireless LAN, and the name. And if I go back to my pin, I am connected. So you are going to see me watch this ping from time to time, and it's getting connected. I go back here. So what I can do right now, let me put this one here. Let's minimize this a little so we have something nice. And I open a new terminal so I can do some Python here. So I copy it to my, go to the big one, there it is. I copied the path of, I copied the path of the file that I just created, there it is. To the reactor. If we take a look, this is the file that I just created 5 seconds ago, 5:15, I'm still connected. So what I can do, I can run this python.demo, and in the most boring demo ever, this will connect to the drone, wait a couple of seconds, and give me the battery. I don't know if I press enter or not. Yes, there it is.
85%.
The battery is 85%. Again, sorry, this is not cool at all, but I am connected. This is really coming from the drone. Let me show you how we can make this a little more interesting. So one way to make this a little more interesting is let's add more time here in the time sleep. And instead of showing the battery value, let's show the full list of responses from the drone. So I will print the full list of the state of the drone. So I can go back here. Let me clean this, and let's run this function again. And this is all of the info that I'm getting from the drone. If I start to move the drone, there is some weight there also in there because, yes, one of the values that I am getting here is the accelerometer value. So as soon as we finish, 25 seconds is usually good enough, but as soon as we finish, I can start to analyze this data, and you are going to see that I have a pitch, roll, and yaw, which is basically the 3 axes of the current state of the drone. I have the AGX, AGY, and AGC, the accelerometer values, which is the coolest one for me. I have the temperature also available here, the high and low of the temperature in Fahrenheit values, time of flight. Somewhere there is the battery, probably this view didn't get, but I have a lot of info here. And this is the place that I pick up this string, did some kind of, let's create an array, and I know that the battery is in the position 21. But all of this info is coming from the drone. And this is kind of super cool and easy because if I go back to the code, and I know I don't need to brag about this, this is super cool, but hey, with 90 lines of code, I create the core, which basically allows me to access to the drone and start to interact with the drone. And by the way, I only did read information from the drone. If I want to make the drone fly, I will type something like this, take off, or as far as I'm up 10, so it will take off, then up 10, do flip. I need to check the PDF with the commands, but this is the only thing that I need to do to interact with the drone. However, which is the cool part here, let me delete this because if I run this by mistake, it's not applying here, and I will hit myself. The next step will be access to the camera. Let me disable Copilot. Is the access to the camera. Mm-hmm. When I start to do the camera stuff with the drone, I try a lot of stuff. I try to access to the camera using the VLC, using a lot of tools. I find a couple of ways to do this. However, working with Python, I realized that we can use OpenCV, and OpenCV basically makes the live accessing the camera to the drone for us super easy. Okay. Because OpenCV just set up some context in case you don't know. OpenCV is one of the most popular libraries to manage images. It's been created by Intel 10 or 15 years ago. It's kind of very old. It was very popular. It is written in C++. Then you have a lot of wrappers and implementation in Python, in C#. You can use it also in JavaScript. So there are a lot of flavor here. But the cool thing is to access the camera of the drone, I only need to write 10 more lines. So let me show you.
Cool.
So I will go for my general code. This is the code that I just write. This is my sockets, my functions. The only difference that I have here is that in my import, remember that I'm using sockets, time and threading. I also have OpenCV. This CV2 is the OpenCV library. You can install this with 2 lines. With pip install in Python is very easy, but the base code to access the camera is here. The only change that I need to do is basically when I connect to the drone, I will send a command. Remember that we need to send a command to start the interaction. Yes, and I will send another one called stream on. This stream on will tell the drone that, hey, open the port for the camera and start to do the stream off of the camera frames.
Oh, cool. Okay.
Yes, and this was not in the PDF. So I can't remember where I read this, but you need to do stream off to access the camera. But then once you are here, it's camera 101. I did a lot of OpenCV code in my life, and this is the main lines that you need to write to access to a camera. Okay. So I have an address here, which is going to be UDP, my IP, and the port. The port is 11,111, and then I will create a video capture element using this address. And OpenCV will do the magic, and I will have this cap variable, which is a video capture element, and I can say, cap, give me a frame. Cap, give me a frame. It's going to give me the real-time frame of the drone camera.
Yeah. Okay.
Yes, and the cool thing is that if I change a string here, video UDP, by 1 or 2, it's going to access your local cameras, depending on the index, and it's going to give you the frame of the camera. If instead of using UDP /IP, whatever, you have the address of an HTTP camera, you are going to access the camera. So OpenCV does basically
very powerful.
It's super powerful and do all of the work for us. I don't want to minimize the work here, but it's super easy. I try a lot of ways. This is the easiest one. So I have the capture. So let's show the camera frames. So again, remember, crappy code. Let me put this one here so we can see it. What I have here is I will have a eternal loop. Try to work until I close. I will use this send command for the battery, read the battery values, kind of a ping to the drone, so I know that I am still connected. And then, this is the important lines, I am going to say capture, the one that is capturing the video, read the frame, I'm going to resize the frame, and I'm going to show the frame in an OpenCV window viewer that they have there, which is, you can show it here very easy. And then if I press the Q letter in my keyboard, I'm going to stop this. So let me change here the text. So let's do Reactor Rocks. Let's change the title. And that's basically the app. It's going to connect to the drone. It's going to open the camera. It's going to send the command to start the SDK, start the camera, connect to the camera, and start to show the camera in a window. The only extra line that I need to do is that at the end of the application, I need to send this. We need to send this stream off command to the drone, so it's close the camera. If it does, if I don't do this and I close the app, sometimes the drone gets kind of crazy. I need to take out the battery, wake up,
like reset it.
Yes. Again, this is a toy, so it's not prepared to be these kind of things. But this is all I need to do to access the camera.
Okay.
So let me go back here. Let's go to my big. Oh, not here. There it is. So let's do this. Let me check if I save the camera. Yes, there it is. The camera just saved here, and I am connected here. So I am going to connect again to the drone. The cool thing about connecting to the drone from time to time is that I can drink some water.
This is really, really cool. I could see you spend a lot of time tinkering and I bet it was pretty frustrating too, just like things that weren't working out.
Yes, I mean, it's fun. It's for me, it was an excuse to learn this new set of technologies, and it's kind of work. By the way, this output, I just run the camera file. And this output that we see here is the log from the OpenCV, and that's me. That's the drone. You are going to see this flying in front of me. That's the camera. Cool. This is not my office. This is a green screen. This is a photo from my old office. You are there somewhere here. So this is kind of Inception, going camera. But hey, that's the camera drone. That's how easy it is to access here. And I can even, I can even show you that this is the one that, oh my God, that's mine. This is the Reactor Rocks window that I created.
Cool. Yeah.
But we can do a lot of stuff here just with these lines of code. I can start to work with this image. I can start to do some object recognition, computer vision, or this is basically the next step. But 10 more lines on top of the ones that we write at the beginning, and we can connect to the drone, and it works really great. And by the way, I am doing the resize here. I didn't talk about this. I am doing the resize here just to get a small window so we can interact. But if I don't do a resize and I show the full image, it's going to show the 720p, which is going to be. It's not a full screen image, but it's nice. It's good enough to basically show. To do some computer vision operations on top. The main question that I usually have here is that how fast this is working. So we can add some lines of code. So let me delete this. We can add some lines of code to basically show the frames per second. So it's going to be basically the same, but at the beginning I am going to grab the time, and once I have my image, I'm going to do some crappy algorithm here to get how many frames per second I am showing. I am going to show the frames per second using OpenCV also to put the text here in the window.
Okay.
And you are going to see that it's good enough. I mean, it's not.
Toy?
For a toy, it works in the. And by the way, I am connected here. The drone is close enough. So if I stop this one here and I get here, I have a 249 frames per second.
Okay.
I am not moving the drone. Let's start to move the drone around. And if I start to move the drone, you are going to see that go down to 40, 50, 30 something. So 40 something here. So it's still good enough. And remember, and I'm running this very close to my computer. If I run this outside and I put the drone 5-10 meters away from the antenna, it will drop. If I have a very crappy, I have a lot of signals here internally, it's probably going down, but in the 20s or 30 frames per second is good enough to do a lot of stuff. And hey, it's kind of work. If you see my camera and you see the response of the camera, real time. It's almost there.
I mean, for $100 drone, this is very impressive.
For a toy, is there, and we are still good in the demo mode with 77% of battery. I have extra batteries here just in case, but that's another one. So SDK to access information to the drone to make it fly, not flying yet, to access the camera. We almost have half of the session done. Mm-hmm. Before moving forward with the frame, with the object detection, let me set up a little of context about this, about face detection. Yes. Also, a tricky topic because we can detect faces, but we can also do face recognition, which is also a tricky topic right now. I am using this as a sample of what we can do with the camera, but I am going to show you also how you can do object detection or other techniques so you can see how it works. So you can do a lot of stuff. I write this a lot about creating your own machine learning models to detect objects. I am doing here HoloLens. You can do face recognition. You can do detect facial features. I have this old animation with my little daughter in the stuff. And yes, and it's all Python. And the idea is that you can pick up an image and you can analyze an image. Mm-hmm. And because we already see how we can get this eternal loop with the camera, accessing the drone camera images, we can start to do these kind of things, analyze faces, detect faces, do facial features, detect objects. So it's possible, it's there. The only thing that we need to think here, we need to be aware that, this process, face analysis, computer vision, and this kind of are heavy. Depending on what you have, they are heavy. So depending on what you need to do, you are probably going to add a second or a couple of seconds delay on the camera, but it's something that you can do here. So if we want to start with the easiest way to do face detection, we can go back 20 years. Yes, this is super old. And one of the most popular face detection algorithm back in the 2000s was the Viola Jones detection. And it's based, not going to go deep there. If someone wants, we can talk about this later, in hard cascade approach, with basically we need to pick up an image, make this image convert to a grayscale, and then we will start to apply some algorithm and math there to identify these zones. And when we find kind of the T-zone of a face, which are our eyebrows and the nose, that will be a face. It's a little more complex. This is a very...
It's a good...
Yes, this is a very simple way to explain this. These guys are super smart, but that's kind of the idea. That you have the eye region is going to be darker than the upper cheeks, the same with the nose. So with that, we can detect faces. And the nice thing about this is that in order to use this, we don't need to download 100 megabytes, or bigger machine learning model. This is just a very small XML file, and it can be used very easily in OpenCV. So with that, I'm sorry, by the way, this is the OpenCV repository.
The repo?
Yes, the public repo. They have these hard cascades to detect frontal faces, to detect eyes, to detect smiles, to detect bananas. They have a lot of stuff there. Cool. And the way that we do this is basically in these lines, between these two lines, we are going to analyze the frame, pick up the frame, and start to basically work with the frame. So let's create a third one, so it will be easier for someone later to, face.pi. So let's create a third one. And again, common code, everything that we already seen here, OpenCV, send, receive commands, battery functions, opening the camera, yada, yada, yada. And the important lines are this one. I am going to load this XML with the cascade definition. This is the XML that has the definition of how to read an image. And then I am going to analyze the faces. So in the eternal loop that we have accessing the frames, once we access a frame here, we are going to convert the frame to a grayscale image. And then we are going to say, hey, cascade, see if you can detect any face. And if you detect a face, it's going to return an array with 4 coordinates, top right and bottom left. So we are going to be able to draw a rectangle, a frame, for a camera, for a face. And that's it. The only thing that we need to do is these 4 lines when we analyze the frames to to show how we can detect faces. Let me copy here because I don't have the hard cascade file. Yes. Which one I am using? The front face. Yes. So let me copy here the file in the same directory. There it is. And by the way, this is what you find inside of a hard cascade. It's a huge XML that defines this operation that's going to be. Again, we can talk about this if we want. You can even train your own to detect object. It's not the best technique to do this, but I think it's good enough to learn.
Okay.
So back here, let's see if I have everything that I need. Yes, I have my face file, my hard cascade file. Of course, my drone is disconnected. So let's turn on the drone. There it is, and try to connect.
It's very impressive what this library OpenCV is capable of doing.
Yes, because also the next demo that I'm going to show, it's basically is how we can do this access to the camera and detect faces, but instead of using the hard cascade, using a pre-trained machine learning model. I am not connected. I am missing something. But instead of doing the hard cascade, we are going to use a machine learning training model, and we only need to change these 2 lines for 4 lines, and that's it. So
wow.
It's an amazing layer on top of the abstractions that we can use for this. Let me go here. I missed something here. I can't remember what. Hard cascade, open true, which is my line of error. This is happen. Oh, it seems that it couldn't connect to the drone. I should be connected to the drone. Let's double check. I have the reply, yes, so let's run this again. So it should open the camera right now. There it is. Somehow it didn't access the camera fine. And when I start to move the drone and I put the drone in front of me, if it starts to refresh, I think it gets, oh, there it is. It's have some kind of lag. At some moments, I will start to see it's getting disconnected, but you see a red frame there.
Yeah, I see it.
That's that's the hard cascade. And as I mentioned, this works kind of great. It's not the best approach. This hard cascade was trained with a lot of Caucasian faces. So if you have some Asian face or a different kind of ethnicity, you're probably going to have problems there. There are much more better ways to do this. But hey, this is cool enough to see that once we have the image, we can run this image of any machine learning object detection computer vision model and do magic. I have another example here. I am not going to write this from scratch. We don't have time. But this other example use a deep learning model trained specifically to detect faces. It's kind of heavier on the work because it's going to do much of this using this machine learning model. It's heavier. By the way, OpenCV will give us the chance to use this model, so we don't need to learn TensorFlow. We don't need to learn PyTorch.
Yeah,
it's good enough to. Yes, it's good enough to do this. And again, once we have our lines here detected, we are going to analyze the frames with this, and if we have something, it's going to be drawn in these bounding boxes, which are the frames. So if I run this demo, this is the 45, you're going to see that it's kind of slower, but it's also good enough because it shows that we can do much more that use, again, hard cascades are fine. Hard cascades are kind of a good place to start, but when you are here and you start here, you are going to see that.
Okay.
Yes, and this model is much more better. With hard cascade, it only detects faces when you are looking at the camera. This model will detect the camera, the face, even if you have some angles here or whatever. So it's super, super powerful. And again, I am running here at 20-something frames per second.
It's impressive. So,
It's kind of heavy to do there, but you see the angle there. I am looking to the side. I'm still showing my face. And the code is the same. The code is iterate to the camera loop and show how can analyze these faces. I did a lot more. I have one that, oh my God, it never works. Let's see if it works, which is another model that I found in the internet. And by the way, these models are usually free. You only need to understand how to use them.
Right.
But this one it's going to do age and gender analysis, which is always nice. So you see how I get my
interesting.
heads out there. Come on, up. I need to get down or what? There it is. So I am a male between 25 and 32, no, 0 and 2, no. So it's not a very accurate model. It's very bad. Also, this is the moment that I started to get some lag. I need to improve my code because you see that it's not doing in real time. So we have kind of a big buffer to get work. But again, it's just a model that is analyzing the camera frame. I am also showing here how you can crop the image to use the image software there. And that's it. That's a very simple way that you can also do this age and gender analysis. Again, all of these models have some, be careful with these models, they have some bias, you need to be aware of the limitation of the models, but using them, it's super fun. And this is kind of a nice excuse to learn about all of these things.
Absolutely.
So the last topic that I want to share in one of the session talkings about here, by the way, I haven't checked the chat. I see that there are several questions and comments. I will try to answer, unless when you find something which is hot right now, I will try to answer everything at the end.
We could save it to the end. It just here we have Hassan asking us, just wondering if the SDK is available somewhere, and you have all this in your repo that we've linked.
Yes, and I see that you shared the repo there.
Right here.
It should be up and running. You can check. I mean, for every session, I add some new stuff. So if you go for any drone AI for the latest one, you should find everything like this. But yes, everything is there. There are also, I am going to share, there are people who created really SDKs to work.
Okay.
100 lines. But yeah, that's a good place to start.
Fantastic. Awesome. And here's another comment for you. Stay hydrated, Bruno.
Thanks, Gwyn. Okay, and the final 10 minutes, the final topic here to talk is around in one of the sessions, someone asked me about, hey, is this, the drone can be an IoT device? And yes and no. I mean, we can't run IoT here. The only thing that we can do is we can connect and we can process this data. And we can send this telemetry, in example, to Azure IoT or Azure IoT Central. This is kind of the two main flavors that we have in the Microsoft world today, where we have Azure IoT Switch, which is kind of the super powerful and configurable platform to do IoT solutions. And IoT Central is kind of it has an abstraction level on top that it's easy to create dashboard, it's easy to create some connection and exporting. We don't have deep control like we have in IoT Suite, but it's still an amazing. So I was thinking, okay, let's do something in IoT Central because it's easy to prototype. And by the way, anyone can create and test Azure IoT Central. There is a free version to test for a week, and I think that you only need to have an Azure account, which is also kind of for free, or you can have an Azure Pass. But the idea is that once you create an app, once you are here in Azure IoT Central, you can create an application. And this could be a full topic to talk about. But the idea is that you can create templates for devices. And each template, we have a couple of properties. You can define properties like I did here for accelerometers, or the battery value, or the temperature. These are going to be telemetry. You can even define some specific data type like acceleration or velocity or data rate. There are plenty of things that you can do here. And then for a device, you can define some views. So I will have here a view, and this is a template, a view with a historic chart of the accelerometer values for X, Y, and Z. And then I will have another view that is going to show me kind of the real-time value of the battery and the temperature. That's it. Super simple. That's my template. And then once I have my template, I can create a device. And the device is basically something like drone reactor 1. I will define a name and ID. I will use my template. And once I have created this is my device. I can connect a piece of code to start to send and interact with Azure, send information and interact with Azure IoT Center. The only information that I need to know is basically this device connection, when I have a scope, a primary key, and a device ID. And what I did in order to make the connection here, to make the magic, is I pick up a sample piece of code that is available in the Azure IoT SDK, and I create, let me go back here, and I create, let's go to the top. This is the same code that we have already, that we did already before. The only difference here is that I am using, I create a class here, it's a drone device, which is a class that I copied and adapted from the Azure IoT samples. And it's basically going to send telemetry to the drone and send some properties to the drone. But everything is encapsulated there. I'm going to share this later. So the same logic from the drone. Main difference here, I am going to get different values for the battery, accelerometers, X, Y, and Z, temperature. And once I have this info, and I have somewhere here the internal loop, I am going to send the info. I need to define again the scope, the device ID, and the key. This is the connection string. This is basically the connection credentials that I am going to use to get here. And let me see, this is the one that I always forget to copy the. There it is. Let me copy the key and the scope. There it is. And in the internal loop that I'm going to have, I am going to basically send the telemetry and send the properties every 5 seconds to the Azure IoT. So if I copy the part of this one, I go back here, I don't have any data, so let's do some magic and see if we can make it happen. So again, first stop will be Python 76. Will be, let's double check if, okay, it's disconnected as usual. So let's connect. And as soon as the ping starts to give me some data, it should be now. Come on, ping. It's on. This is the demo gods in the last demo. 1, 2, 3.
It always happens.
Yeah, but it's okay. I have unreachable and one more. We should be there soon. There it is. So I will run this. It's going to start to do some magic. It's going to start to create the connection string to connect to the Azure IoT. I will have the image somewhere here, and I started to send information here. So if I go in my drone to raw data, this is what I have from the drone. This is the info that I am receiving right now. Accelerometer, no values, it's still here. Telemetry with this. So if I start to move the drone around, we will see that it started to show kind of a chart here. If I go back to raw data, we have more data here.
Very cool.
Now the telemetry is here. So we have these accelerometer values, X, Y, and Z. And it takes some time to refresh the chart. So after a couple of seconds, we are going to have real values here. But hey, this info is coming for the drone. I can even check and see that my battery here is 71%, which is kind of cool. And it's the same value that I have in my. Oh, they're starting to show show this. It's not real time. This is not kind
Yeah,
of
there's a
a
delay.
real time analytics, but it's good enough to show, hey, with a couple of lines of code, I can get here, and this info is coming real time from a Python app. So it's not IoT per se because we don't have anything here, but we are
Yes.
doing kind of a bridge to send the info to the chat. So I will leave this here, sending info, and start to, we have 10 more minutes, so start to wrap up this with the stuff that we just seen today. So quick recap before going to the Q&A. Drone SDK, I show how we can create one from scratch. It's not the best one, but it's doing the magic. How to read the telemetry from the drone, which is basically accelerometer, battery, all of this kind of data. How to access to the camera, which is the cool part. If you are interested on computer vision, this is an excuse to do something because you can program the drone to fly and follow faces, follow a ball. If you're holding a banana, you can hold your banana. It's fun. It's really fun to do that. And then, again, with a couple of lines, using the predefined classes that we have in the Azure IoT, how we can create this. I'm going to share the slides. In the slide, I also add to the end the official Amazon page to get the drone, the SDK, how I write. I wrote a lot about this, the Viola Jones, a lot of stuff that you have here. And hey, I am a couple of minutes late over there, but I hope, and I go back to the chart. Oh, we have small little lines in the chart.
Yeah, we're seeing some data populate into that. This is very, very cool. I think if anything, this is like a fantastic example of how, we don't need to build things from complete scratch. We can like utilizing services like, Azure IoT and these libraries in Python and putting together, SDK built on some information that's available out there. It's like, and $100 like toy drone. It's pretty insane, like the things that like we're now capable of building if we piece these things together and using, the power of cloud computing as well.
Yes. And again, for me, it was an excuse to learn about multi-threading, to learn about sockets and communication. I did a lot of this programming, but never in Python. So somehow I get there. And also my huge aha moment was, oh my God, how easy it is to access the camera. And I am a very big fan of computer vision. I did a lot of. So I start to do, okay, let's follow faces. Okay, let's follow a banana. Okay, if you detect a face, do a flip or whatever. You see my camera, I don't have a lot of space here, but I promise if we ever have the chance to do this live, I will make the drone fly. And there are some videos of the drone flying around. Sorry about that. They are not very accurate, but it's good enough to learn and try.
Yeah, and we have your GitHub link with, I'm assuming, and then you mentioned you have a blog there as well. Where can they find more like videos like you just mentioned on the drone flying?
I am going to share later in Twitter a couple of video, but yes, if you go to the GitHub, it's most of the code and also the links to the slides. And if you share online, you're probably going to see me playing around in Twitter. I have small videos of the drone, following the face of myself, or following my daughter, and these kind of things. And again, it's not a professional final product, but it's a good step to learn how to can do these kind of things and how you can start to program this stuff.
Do you have any like improvements in mind that you want to add to the project, or are you leaving it as it is? Or
No, the DJI team, they created a new model, and I am still trying to figure out how to get one. It's not released yet, which basically has kind of an Arduino on top with a couple of plug and play, so you can connect some sensors. And that's a step closer because that is a place that you can deploy code. So we can run machine learning on the edge, tiny machine learning on the edge. So I am hoping that I can have one of these as soon as it's available to see how we can, I don't know, maybe create a custom vision object detection model.
I can't wait to
right there.
Yeah, for you to get your hands on something like that, because then the connectivity issue and the lag becomes almost like minimal, right?
We are running everything on the
everything
edge.
Yeah.
Which is kind of the idea. But again, I know that I can't remember when, I think it was this summer, they promoted this new drone. They make a presentation, but I didn't listen about any dates or whatever. As soon as it's available, I will talk with the family to get a new drone.
Very, very cool. I think we've got all the questions. People are just like very excited, saying this is really cool. Here you go. It's a really great thing. I appreciate your time and effort. It's 8 a.m. here in Australia, and it's very exciting listening to your topic. Wow, nice and early, starting your day off with some interesting drones, some face detection, some Azure IoT kind of stuff. Fantastic. I think we've got all the questions actually. Bruno, any last comments? Anything you want to share?
No, thanks to all of them. Thanks to you and the team behind the
Gracias,
reactor.
Che.
Gracias, Che. Gracias, Kike. And hey, I'm looking forward to show as soon as I get a new idea, I'm looking forward to show the improvements here because again, it's a fun way to learn and this is the way I like to show stuff.
Awesome. Well, Bruno, thank you very much. I know Rebecca usually comes on towards the end and promotes a little bit more before we end the whole thing. So if anyone has any last minute questions, put them in right now before it's too late. Or you could always follow Bruno on Twitter too.
Yeah, that's true too. At El Bruno. I'm right now, my lighting's lacking here, so I'm like in a dark cave. But thank you so much. This is really great. It seems like the audience absolutely loved it and the content and everything. I'm just going to quickly ask everybody to submit a survey. This is our plug. We use this information not to anything crazy. We just need it. We like it for content development. So if you kind of let us know a bit about you, our audience, we can try to target that a little bit more on the stuff that we're putting out. Although, obviously, our wonderful speakers also just like to showcase the things that they love too. So it kind of goes either way.
Yeah.
But definitely give us your feedback. I dropped the link to the chat. Event ID is 14728. I stuttered. 14728. And yeah, if you aren't familiar with the reactor, check us out. We've got MicrosoftReactor.com is our main website. We're also on Meetup. You can find us on Twitter. And if you want to revisit anything covered in today's session, you can find us Microsoft Reactor channel on YouTube. We're getting a lot of thank yous coming through as well.
And a shout out to my mom right here, Peña-Siguenza. That's
hey,
my mom.
Awesome.
We have a lot of content coming out, and the YouTube reactors constantly there's new stuff all the time. Different time zones, you'll find something live most likely going on. Thank you everyone. Bruno, amigo, muchas gracias. Estamos en contacto. Maybe we'll do something in Spanish sometime soon. That would be very cool.
That will be very cool. Yes, we need to give. I always like to give back some love to my Latin American and Spanish friends, so we can do something in español. Va a ser un placer.
Por supuesto. All right. Thank you, everyone. Rebecca. Thank you, Bruno. Rebecca.
Thank you all.
Everyone, chat. Thank you so much. We'll see you in the next one.
Take care.